Hello guys! In Malaysia, I receive a lot of inquiry and proposal to design a sound system for a bare multipurpose hall. What do I mean by bare? Bare means there's no acoustic treatment. The floor, the ceiling and the wall is mostly concrete. So this is a very difficult to design because this kind of venue have very high reverberation. So therefore, I would like to experiment with a computer simulation which design, whether line array or distributed sound system, is better in providing more clarity and intelligibility for the audience. So let's jump into the software. I'm using EASE 4.3, as you can see in my laptop, and actually I have constructed the venue. So this venue is 40 meters by length and 30 meters by the width. So this is a typical size of multipurpose hall in Malaysia. So what I've done what I have done here, I have already put all the speakers array at the front of the stage, and I have two type of distributed system for my testing. So first one, I have the column system, which I have 6 unit of column installed at the left and the right. And then the next one, I'm testing the full range speaker system, total of 6 unit, and 3 at the left and 3 at the right. So I shall simulate and see which one will have better clarity. So I will be using the STI, speech transmission index, to justify which one have better clarity. Before we start, I shall check all the data for this venue. For example, this wall F3 is concrete, and then the behind wall, it is concrete, and then the floor, it is concrete. So it's confirmed that this venue is all by concrete and is highly reflective. Then I shall show you the array. So I'm using TurboSound Liverpool TLX 84. So 10 unit per side. So I have 2 cluster, and this is how it was flown. The angle and the quantity is here. Next, I'm going to show you the full range speakers. So I'm using TurboSound TQ15. This is the latest high-end full range speaker from TurboSound. I'm using 1 unit at each location. And then, as you can see from this front view, it's tilted down. So the sound is aimed to the audience. Okay. And then for the column, I'm using a column from Axiom Pro Audio, the AX12C. So this is column, and you can see from the front view, it is aiming at the audience as well. Okay, so this is our simulation venue and the system. Okay, so because simulation takes a lot of time, I have simulated all these 3 systems. You can see from here. Okay, I have all 3 systems here. So at this left side, so this is the column system. Okay, and then the middle one, it is the full range system. You can see from this information. And on the right side, it is the line array system. So this is simulated the direct SPL at 4,000 Hertz, same as this both. And you can see actually for direct sound, the line array has quite even distribution between the spaces. Even the column have good distribution, except for the front part and the back part. And then for the full range system, this is the worst for 4 kilohertz. You can see there's a lot of green color area, which is actually the SPL is lesser. But of course, this is a highly reflective area. So let's examine the total SPL at this kind of venue. So total SPL is actually taking note of this reflection sound as well. So direct sound, it doesn't take note of this reflection sound. So I'm gonna simulate the total SPL for the column, the total SPL for the full range at 4 kilohertz, and total SPL for the line array. And you can see, of course, the line array is very loud. the line array is very loud, it's almost pink color, but it's quite even. And then for the middle one, the full range, okay, is more evenly distributed. And the column system, we have problem with even sounding. This is at 4000 hertz or 4 kilohertz. Okay, so how about we examine other kind of a frequency? Let's change to 1 kilohertz. So as you can see at 1 kilohertz, you can see actually the full range has better distribution compared to the other two. As you can see, for the line array, we have this higher SPL in front of the speakers, while the dispersion at the off-axis area, you can clearly see actually is slightly lower. I think it's about 1 or 2 dB. So I assume that this is 109, 108, something like here, and this is about 111. And of course, for the column system, for those who sit near to the column, will be very loud. If you're further from the column, then actually you get quite an even sound. Okay, overall I would say the full range, I think, doing a better job at 1 kilohertz. So let's examine another frequency at 500 hertz just for fun sake. And for 500 hertz, I don't think we can see the difference. It's all the same color to me. I need to further detail to inspect it to see any difference, so I would not further inspect it. Okay, wasting the time for now. So now let's change to SDI measurement and see which one have better SDI. The SDI is a measurement of clarity, the Smith transmission index. So basically, it have this measurement from 0 to 1. Of course, the 1 is the best, and then 0 is the worst. So overall in Malaysia, there's a understanding that in a worst case scenario, anything below 0.55 is considered is very poor in terms of intelligibility. We need to achieve above 0.55 in order to have minimum intelligibility for that kind of venue. So let's have a look at this kind of venue. So basically, you can see, let's start from the line array. Okay, basically for this kind of venue, without any acoustic treatment, the line array system perform very poorly. You can see the distribution. Okay, you can see it is below the 0.55, and then you can see most of these numbers, the SDI numbers, is centered around 0.36, 0.38, and then 0.4. If you go to Google, you can see 0.45. This is centered around 0.38. Okay, so center of 0.38 is actually quite poor. Okay, so for full range speaker system, so it's around 0.32 to 4. So I think it's centered around maybe 0.36. If you compare about this is about 0.38, not much different. And then for column speaker system, okay, we have centered about 0.45. Okay, so basically from this data, a distributed system doesn't mean it's better than line array system, but you also need to have the correct distributed system. For example, for this case, I think the column performed quite well because it has certain areas that are near to the speakers, as you can see from the simulated area. So definitely have better SDI. So of course, nearer to the speakers, you become more red, which is, I think, is about 0.7. 0.7 is actually very, very good intelligibility. If you look at this, 0.7 is actually good and excellent. So those who sit near at this proximity of this column speaker will have a very good intelligibility. However, if you sit into the middle, which is about light blue, I'm not sure what is the numbers there. I believe light blue is about 0.5 something. I think this one. I think this one is 0.5, which actually is average fair. It's under fair. Okay. Of course, you can see at the front of this, at the front of the venue, at the back of the venue, it's become very poor. So maybe this design, instead of using 3 column per side, I need to use 4 column per side to have better STI. So based on this simulation, so I would say in this kind of high reverberation venue, a distributed column system will perform better than the distributed full range speaker and a line array system. With this software, I also can simulate the real life audio quality. So for example, let's say I'm going to simulate on the line array. I put this Walker on. Let me see, where is this guy? So this guy is here. Let's go to the best area, which is directly in front of the speakers. Okay, which is at this area. So I'm going to simulate the audio at that particular venue, and I'm gonna have 50 order of the reflection, so this is more accurate. Okay, and then directly to ears, and then okay, and save, and I'm wait for a while for this software to come out with the audio source. Okay, so it's done simulating the audio quality. So before I play you the simulated audio, I play you the original file. Open this mail vocal.
Sound. It's not just the air vibrating. Sound means feelings. It refreshes our minds, soothes our hearts. It can make us happy or sad or excited. It also is essential to the communication of ideas and the exchange of information. It's vital to daily life.
So that was the original MP3 file, the WAV file. So now I'm going to play you the simulated audio at this location in front of the line array. Okay.
Sound. It's not just the air vibrating. Sound means feelings. It refreshes our minds, soothes our hearts. It can make us happy or sad or excited. It also is essential to the communication of ideas and the exchange of information. It's vital to daily life.
Okay, you can clearly hear the echo. So let's move to another position. Let's go to the back. See how worse is that compared to the front part. Let's say to the very black, the dark blue color. Actually, this is not the worst. You see, the worst one is in the middle. You see, the light blue is the worst. Okay, but let's hear the back.
Sound. It's not just the air vibrating. Sound means feelings. It refreshes our minds, soothes our hearts. It can make us happy or sad or excited. It also is essential to the communication of ideas and the exchange of information. It's vital to daily life.
Okay, it's clearly quite echoey. So let's try at this middle area just in front of stage. This is normally the place where the VIP sit, and this is normally where the blind spot is. This is normally where we want to put the center cluster of here. So we just have a listen. How does this sound?
Sound. It's not just the air vibrating. Sound means feelings. It refreshes our minds, soothes our hearts. It can make us happy or sad or excited. It also is essential to the communication of ideas and the exchange of information. It's vital to daily life.
Okay, this center area in front of stage is clearly the worst area in this venue. So it is indicated by this color, the light blue, as you can see. Okay, next we move to the full range distributed system, and let's see which two areas we're going to examine. We're going to examine the dark blue and the light blue. It's obvious that the light blue is actually the off axis of the full range speakers. Let's test the light blue area first. Okay, let's place this between these two speakers, and then we're going to simulate.
Sound. It's not just the air vibrating. Sound means feelings. It refreshes our minds, soothes our hearts. It can make us happy or sad or excited. It also is essential to the communication of ideas and the exchange of information. It's vital to daily life.
Okay, it's clearly very echoey, and definitely because this is a off-axis area of the loudspeakers. So let's try another area. Let's go to the middle where the dark blue is 50 and to the ears.
Sound. It's not just the air vibrating. Sound means feelings. It refreshes our minds, soothes our hearts. It can make us happy or sad or excited. It also is essential to the communication of ideas and the exchange of information. It's vital to daily life.
It clearly that even at this middle area, which is the dark blue, the best part for this venue with the full range distributed system is still not performing well. So next, let's move to the column, and I'm interested to test few area, the pink area, in the middle, the purple area, the off-axis light blue, and the dark blue area. Okay, let's try the, where's my cursor? Okay, let's try the pink area, and this one should have the best intelligibility.
Sound. It's not just the air vibrating. Sound means feelings. It refreshes our minds, soothes our hearts. It can make us happy or sad or excited. It also is essential to the communication of ideas and the exchange of information. It's vital to daily life.
Okay, clearly they still echoey, but because the direct sound is much more prominent than the reflected sound, that is why at near this place, the sound is much more clear. From this tree design, it's clearly that the distributed column speaker will have better intelligibility for this venue because it's nearer to the audience at the side, but there is some off-axis area which not covered, so perhaps instead of 6 unit of column, we need about 8 or 10 unit of column to achieve this good intelligibility for the audio. Okay, if column is not in the equation, so between the full range distributed system and the line array system, it's clearly that the line array is slightly better than the distributed column, is slightly better than the distributed full range speakers because there is a lot of off-axis area in the venue. So there you have it for empty hall, concrete wall, concrete ceiling, and concrete floor. So the best system is a distributed column, and the second one is a line array, and the final one is a full range system. That is all for this experiment, and see you again, and bye bye.